Hi, this is Jim Cooper, and welcome to this module on creating and using JavaScript objects. As part of this course, we'll explore 3 different ways to create objects in JavaScript: object literals, constructor functions, and classes. In this module, we'll focus on the first 2, object literals and constructor functions. We'll also explore some important concepts related to working with objects, like object equality, merging object properties, and immutability, plus a few other handy tricks and shortcuts in working with objects. So let's jump in. To help get us started quickly, I've created this small GitHub repo, and I'm just going to go ahead and clone it. If you're not familiar with Git, you can just use this download zip and download it locally. That's fine too. But I've got Git all set up, so I'm going to go ahead and clone it. And now that that's cloned, I'm going to go ahead and open it up in Visual Studio Code. And now I'm going to right click on this demo HTML file and click Reveal in Explorer. And then I'm just going to double click that to open it up. Cool, so we have this site that says Hello World, and I'll resize that off camera. Okay, so now we have our web page over here, and we just have it kind of small so we can look at it on the side, and it's displaying Hello World. So where is that Hello World coming from? Well, this is a very simple project. You can see there's just a few files here. And this first one, this demo HTML file. And it's really simple. It's just loading these 2 script files here. And it has this h1 tag where we'll display our output. And you don't need to worry too much about this file. We're not really going to be spending time in here. This is just a little helper file so we can display the results of our code. So let's switch over to our demo.js file. This is where we're going to be creating all of our code. And you can see here, this is where we're displaying Hello World. So as we work with our demo code in this course, we'll write all of our JavaScript in this file. And notice that I've got useStrict up here at the top. I recommend that in all of your JavaScript files so that it enforces cleaner JavaScript. And then we have this function with these corresponding brackets down here. Don't worry too much about this. This is called a self-executing function, and it's just helping behind the scenes with the way our demo code is set up. So we'll be working in this file, and whenever we want to display the results of our work, we'll call this display function. Notice if I change this and save, that it changes the output over here in the HTML. And this display function is defined over here in utils.js. You can see it right here. I don't want you to worry too much about what's happening in here. This is all just part of wiring it up so it automatically displays our changes in our browser. And you can see down here at the bottom of the file that we have this reload.js function. And you can see down here that we're calling that every 1 second. So essentially every 1 second, this file is going to reload our demo.js file so that as we make changes, it will reload it and automatically show up in the HTML in our browser. All right, so now that you understand the environment that we're working in, let's get coding. Let's start by taking a look at one of the simplest and most common ways to create objects in JavaScript, the object literal. Actually, before we do that, let's just talk briefly about objects. Objects are basically just more complex variable types. So for example, we could have a couple of variables like this. And imagine if every time you wanted to describe a person, first name, last name, age, eye color, hair color, you had to declare individual variables and pass each one of those variables around in your program. An object is essentially a way of just grouping information like this together into a single variable. So instead of multiple variables, I could have a person object and I can just pass that person object around in my code, just like I would any other variable. But in doing so, I'd be passing all this information around. Of course, objects can also be used to encapsulate not just information, but functionality related to that object using methods. We'll get to that in a bit. For now, let's see how to turn this data into an object. The easiest way to do that in JavaScript is with an object literal. So first, I'm going to create a variable called person, and then I'm going to set that variable equal to a new object. And this is where the object literal comes in. To create an object with an object literal, you simply define the properties and their values inside braces like this. So here I've created a new object named person with 2 properties, first name and last name. And notice if I call our display function and print out person.name, if I save that, it displays Jim. Well, that was easy. Now I have this person object with first name and last name properties on it. And I could pass this person object around in my code. For example, say I had a register user function and I want to pass in this person into that function. I could do that like this. I just call register user and pass in person as a parameter just like I would any other variable. So that's the easiest way to create objects in JavaScript using an object literal like this. Next, let's talk about the dynamic nature of objects in JavaScript. If you come from a background in statically typed languages, you might be wondering what exactly we just did here. What is person? We haven't even defined a class. Well, that's one of the interesting things about working in a dynamically typed language like JavaScript. You don't need all the ceremony of creating types ahead of time so that you can use them in your code. Of course, the downside is that you don't get static type checking. But in JavaScript, when you want an object, you just create it. Of course, there are times when you want something that behaves more like classes in a statically typed language. And you can achieve a lot of that same behavior in JavaScript. We'll get to that shortly. But first, let's explore a little bit about objects and the dynamic nature of JavaScript. One of the cool things about dynamic languages like JavaScript is that you can completely change the shapes of objects after they're created. Let's say we wanted to add an age property to our person. No need to go back and edit our object literal. We can just add it like this. And now if I come down here and print that, you can see my person has an age. Yeah, 29. That's totally my age. But notice in our object literal, there's no age property. We added person.age after we created the object. That's really powerful, and maybe a little scary sometimes if you're coming from a statically typed language. And I can hear what you might be saying in the back of your mind, or perhaps yelling at the screen. How can you write an entire system like that? Sometimes I need a person to look like a person, and I need to be able to rely on the fact that a person will always have a certain shape. Well, that's very true, and for the most part we can do that with JavaScript. We'll get into that in a second, but before we do, let's take a quick look at functions and how you might add a function to an object. Adding functions to an object is almost as easy as adding properties. You just do it. Let's add a way to determine if a person is an adult. We'll add an isAdult function to our person object like this. So here we've added an isAdult property essentially to a person, but that property is not a value, it's a function. So we don't really call these properties, we call them methods. And then we can call methods on an object like this. And if I save that, you can see this returns true, because the isAdult function returns true if the person's age is greater than or equal to 18. The keyword this that is used right here is a way to reference other properties on the object from within the object. So because this isAdult function is part of the person object, when we refer to this.age, it's going to look on the person object for the age property. And now notice if I change the age of my person to 17, then the isAdult function returns false. And of course, we don't have to add the isAdult function to the person after creating the object. It's more typical that you add it as part of the object literal like this. So you just start with the name of the function, isAdult, and then a colon and the keyword function followed by the function body. So we can delete this down here. And while we're at it, let's go ahead and move the age property up here. And we can delete this down here. And if I change age up here again to 18 and save it, then you can see our isAdult function returns true again. Next, let's take a look at another interesting way to create object literals. Sometimes you'll want to create an object using variables for the property values. To demonstrate that, let's create a register user function like this. And then let's just say inside this function, we want to create a new person object using those first name and last name parameters. What we've seen so far with object literals is just hard coding the property values like this. So we're just creating a first name and last name property, and we're setting those to the strings Jim Cooper. Well, in this case, we want to create a user not with the name Jim Cooper, but with the first name and last name that is being passed in to this function here with these parameters. Well, that's easy. I can just do that like this. So instead of this string here, I'm just going to use fname, and instead of this string, I'll use lname. So you can set object literal properties using variables. Now down here, if I were to call this register user function like this, so I'm going to pass Jim Cooper into that function, and then inside this function, let's just display that user. Okay, now if I save that, there you can see that I'm printing out the person object, and it has a first name set to Jim and a last name set to Cooper, but we're passing that in here and setting those with variables. So I could change this to Chris, for example. And there we go. Our person is now Chris Cooper. But let's explore one more thing. What if these were actually called first name and last name? Then we can use those here like this. And that works too. But this looks a little bit redundant here, where we're setting the first name property to first name and the last name property to last name. Well, it turns out this sort of thing is pretty common. And so in JavaScript, there's a shorthand syntax for this. So I can actually get rid of this duplication like this. And if I save that, you can see that it's still working. And if I change this back to Jim, now it prints out Jim Cooper. So that still works, but this syntax is interesting. If you didn't know about the shorthand syntax, you might look at this and be a little bit confused. But all this is saying is create a person object and set the first name property to a variable that is also named first name. That's the property shorthand syntax. Now let's take a look at an object literal shorthand for methods. You may remember this isAdult function from earlier. It's a method on this person object, but there's actually a more simple way to declare this function using object literal method declaration shorthand. I can basically just get rid of this colon and the word function like this. And you can see that still works. If we change the age of this person to 17, then it returns false. And this function's exactly the same as the old declaration did. But it's important to note that this syntax is specific to object literals. You can't just create functions like this outside of an object. You can use this type of syntax in classes, however, and we'll get to that later. For now, let's take a look at some functions in the built-in native JavaScript object. JavaScript provides an object, that is, an object whose name is object with a capital O. There are several functions on object that we can use for inspecting, manipulating, and doing other things with objects. Let's take a look at the Object.keys function. It's not too common, but every now and then you'll want to discover all of the properties and methods on an object. Let's try it out. The Object.keys function takes an existing object like person as a parameter, and it will return an array that lists all of the names of each of that object properties and methods. So down here, instead of displaying this, we'll display Object.keys and we'll pass in the person object. And if I save that, you can see it printed out an array here. If we make this window a little bit bigger, you can see it printed out first name, last name, age, and isAdult. So it's displaying all the property names or keys of the object, not the property values themselves. Sometimes you'll use that when you want to inspect an object and do something with its properties. In fact, notice if I display person, that it's displaying all of person's properties and their values. So I could have used the Object.keys function when I built this display function, and that would have worked just fine, but I actually used a little different syntax that I like a little bit better, and that is the for in syntax. So that is a for loop that looks like this. So this is just a for loop, and notice that I've passed in the person object here. So this is going to loop over all of the properties and methods in person, and each time it will set this property name variable to the name of each property, which means if I come inside this loop and display property name, Then when I save this file, notice that all of the property names are listed here. And of course, methods like isAdult are properties also. So Object.keys and forIn basically accomplish the same thing. They give you access to each of the property and method names on an object. All right, we've been talking about objects for a little bit. Let's go on a brief tangent to talk for a minute about equality, and then we'll see how the Object.is function is used for equality. Equality is, well, interesting in JavaScript. There are 3 different equality operators we can use: double equals, triple equals, and Object.is. These can all be used for equality, but they behave differently. The first one, double equals, should be pretty much always avoided. It's really only useful in a few rare cases. More on that in a moment. The triple equals operator is much more commonly used and should be used in almost all cases. And then the Object.is operator is less commonly used. It is almost identical to the triple equals operator, with a couple of small mathematical differences, which we'll get into next. If you're not sure what the syntax of the Object.is operator is, it would look something like this. So you pass 2 objects into it, and it will return true if it determines that they are equal. Okay, let's dig into each of these a little bit more. Taking a closer look at the double equals comparison operator, the big reason why we should avoid using it is because it is not type safe. For example, when using this operator, the string value 42 is equal to the numeric value 42. This can cause all sorts of unintended issues, so it's best to avoid this operator. It could, however, sometimes be useful if you're receiving input as a string and intentionally wanting to know if that is the string equivalent of a numeric value, but that's not a very common need at all. Here are some of the other examples where the double equals operator is weird. The number 0 is equal to the value false. Null is equal to undefined. An empty string is equal to 0. And an array of numbers is equal to a comma-separated string of the same numbers. This is all a little weird, so unless you have a specific reason to do this, it's best to avoid this operator. Okay, now the other operators. Triple equals and Object.is work almost identically with a couple of small differences, but both of them are much better than double equals. First of all, both of these operators are type safe, so you can feel free to use either of them. The triple equals operator, however, is much more convenient and concise, whereas the Object.is operator is more verbose. So triple equals is much more commonly used. You should probably plan on using triple equals for equality checks unless you have some very specific needs for the way Object.is works. So how is Object.is different? Well, first of all, with triple equals, 2 not a number values are not equivalent. If you're not familiar with not a number, or non, it is the result of a non-numeric mathematical equation. So for example, if you tried to divide the number 1 by the letter A, you would get not a number. And if you were to compare 2 not a number values, the result is going to be false with triple equals. However, if you compared them with Object.is, it would indicate that they are equal. That is the first difference between these 2 operators. The second and only other difference between these 2 is that with triple equals, plus 0 is equal to negative 0. Positive and negative 0, are those even a thing? Well, yes, in mathematics, there is such a thing as negative 0. Positive 0 is what we usually just call 0. So it is possible to have a negative 0 number. And with triple equals, if you compared positive 0 with negative 0, they would be equal. But with Object.is, positive 0 does not equal negative 0. Other than these 2 differences, these 2 operators are identical. So to just wrap up on object equality, let's talk about what it really means for 2 objects to be equal. If you consider this code, when we create this new person1 variable, that gets stored in memory in a specific memory address like this one here. If we then create another person object, person2, that gets stored in another memory address like this. And if we compare these using double equals, triple equals, or Object.is, the result will be the same. They will all return false. That's because what is actually being compared is not the values contained within the object, but rather the actual memory address of these objects. So that's how equality works with objects, and it's important to note that this is only true for objects, not for primitive types like strings, numbers, and booleans, for example. So consider these two separate string variables that have the same value. These are, of course, stored in two different places in memory. But unlike objects, all of the equality operators will consider these two variables equal. So for primitive types like strings, JavaScript compares their values, but with objects it compares their memory addresses. Alright, that was a quick tangent on equality, and we saw that this is how you use the Object.is function for equality comparisons. Sometimes in JavaScript you'll want to create a new object from an existing one, or merge the properties of two objects together. The Object.assign method allows you to copy or merge the properties from one object to another object. To demonstrate that, let's create a new object. And now let's use Object.assign to copy the properties from person1 to person2. So Object.assign takes multiple properties. The first one is the object that is going to be modified or have properties copied into it. So if we display person2, you can see that person2 now contains all of the properties that person1 had. It even copied the isAdult method. And now if we apply what we learned about equality and compare person1 to person2 and save that, you can see that returns false, because even though the properties are the same between the two objects, they are not the same object in memory. Let's take a look at another example now that might better demonstrate how you might use Object.assign. So instead of this person2 object, let's create a health stats object like this. So imagine you're building a weight loss app, and in one section of the app you gather the person's basic info as shown in the person1 object. And then you gather their height and weight in a separate place as shown in this health stats object. And then you want to merge them together. Object.assign is perfect for that. We can just do that like this. So I'm going to take the health stats properties and merge them onto the person1 object. So if we take a look at that, there we go. So we can see that we have first name, last name, age, and isAdult from the person object and height and weight from the health stats object. But what if we didn't want to mess with that person1 object? Sometimes you don't want to change an object like that. For example, imagine this Object.assign function was inside another function like this. So this merge health stats function takes in person and health stats parameters and then merges them together and returns them. So if I come down here, I'll call that function and then I'll assign the value returned to merged person. So if we display merged person now, there we go. You can see it's all merged together as we would expect. But we have an unintended side effect here. So notice if I display person1, which is the object that we passed into the function, that person1 also got mutated. That's because when we passed in person1 to this function, we then called Object.assign and passed that person in as the first parameter. Remember, Object.assign merges the properties into that first object. So it mutates it. And then it also returns the mutated object, which is why I could return the result of that function call here. So our person object got mutated. But good immutability practice says that a function really shouldn't ever mutate the objects that are passed into it. So what can we do to avoid mutating that object? Well, Object.assign actually takes in unlimited parameters. And it will just merge all of the properties from the objects on the right into the object on the left. So we can do something like this. So here I've created a new empty object literal, and I'm passing that in as the first parameter. And then the properties from person and health stats will both get merged onto that new object. So if I save that, there you can see when we displayed the merged person, it output the merged object. But person1, when we displayed it, did not get mutated. This is how you'll often see the Object.assign method used, with an empty object as the first parameter to avoid mutating the other objects. Object.assign is really handy for working with objects in this way. So we've seen how JavaScript allows you a lot of freedom to work dynamically with objects. Not only can we change property values, but we can even change the shape of objects after they're created by adding properties at any time. But sometimes you want something a little less dynamic. For example, sometimes you want a person object to look and behave the same all throughout your application. Let's say I wanted to work with multiple objects here. So let's change this person variable to Jim. And we'll change that here too. And now let's create another person. So we'll create a Sophia object and set that to a new object with first name Sophia, last name Cooper, and age 17. And then the isAdult function is going to be identical to the one in the Jim object. And let's go ahead and print the age of Sophia. So we've successfully created two person objects. But it's a lot of extra code, and we have a problem. What if we decided that we wanted to update this for a country where the adult age is 21? Well, we could just change this to be 21 here. But now we need to change this everywhere in our code base where we created a person object, so I'm going to have to change this up here also. Right here, that's not that big of a deal, but imagine this was a really large application with thousands of files in it, and you had to change this everywhere wherever you created a person. Well, that's where object-oriented programming and constructor functions come in. So what if we actually wanted to create something that allows us to create multiple instances of person objects all with the same object structure, like a class in a statically typed language? We can do that in two ways with JavaScript, with either constructor functions or classes. A constructor function looks sort of like this. So notice that this is just a simple function, and there's nothing special about this function. Also, notice that it's creating properties on the object represented by this. And then it sets the value of those properties. So more on that in a second. With this constructor function, I can now create a new person like this. Now let's take a look at that person. So we'll just display person. Okay, so you can see that our lowercase person variable is now a pointer to a person object, and that person is named Jim Cooper. I realize this isn't too helpful yet. We don't want all people to be named Jim Cooper. But first, let's explore exactly how this worked. What exactly is happening here? To really understand what's going on, it's important that you understand what the keywords this and new are in JavaScript. The this keyword always refers to an object, and which object it refers to depends on the context of the code that you're executing at the time. So when we executed this person function, what was this referring to? Well, it was referring to a new empty object, and that's what our new keyword does for us. It creates a new empty JavaScript object and sets the context of this to that new object. And then it calls the constructor function that follows. That's really all there is to constructor functions and the new keyword. New creates a new object, sets the context of the this keyword to that new object, and then the constructor function is called, and in this case, that constructor function sets first name and last name on that new object to Jim Cooper. But let's fix this. We don't want all people to be named Jim Cooper. And remember, constructor functions are just simple functions, so we can pass in parameters here like this. And then inside the function, we'll just set this.firstName to that first name parameter. And same for last name. So now if we save this, well, then you see we have a problem. So we have a new person object, but first name and last name are now undefined. Well, that's just because we haven't passed in anything here for the first name and last name parameters. So let's just pass in Jim and Cooper. Now if I save that, there we go. Now our new person object is displaying Jim Cooper for the first and last names. And now we have a function that we can use to create new person objects. These functions are commonly called constructor functions. But you can see there really is nothing special about them. They're just functions. But we use the keyword this inside them and call them with the new keyword. So now let's just add a age property here. And we will add the age and isAdult functions to this object. Okay, and then let's pass in an age down here. All right, and now that we have a function for creating multiple person objects, let's delete these up here, so we don't need those anymore. And we'll call this person Jim, And then let's create a Sophia person. And then let's go ahead and display Jim and Sophia. Cool, so we have two different objects, but we only had to define what the object looks like once. And if I call isAdult on each of these, then you can see that's working, and the logic for isAdult is only defined once. So we're getting some good object-oriented behavior here, and that's really all there is to using constructor functions. Later on in this course, we'll take a look at doing the same thing with classes. For now, let's just take a brief look at the Object.create method. So far, we've looked at two different ways of creating objects, object literals and constructor functions. It's worth noting that behind the scenes, these are both essentially using Object.create to actually create the objects. And we can use Object.create ourselves if we really want to, but you'll see why most people don't really want to. So consider this person object literal here. We could create this same object using the Object.create syntax as follows. So I'm just going to call Object.create, and the first parameter in that function is the prototype that we want to use for our new object. The second parameter is an object that represents the property descriptors for each of the properties that we have for that object. And so here you can see I'm setting first name, I'm setting the value to Jim, and enumerable, writable, and configurable to true. Same thing for last name and age. So now this person object is identical to the person object created above using the object literal. If we just rename these to person 1 and person 2, and then display them. So now if we take a look, there we can see that we have two identical objects. And you can see why nobody really likes to use Object.create, because it's very verbose. The object literal is so much cleaner and easier. And constructor functions actually do a little bit more than this with regards to the prototype. But both approaches are essentially doing this behind the scenes. And you can see it's much nicer to be able to use object literals or constructor functions for creating objects. Here's a quick summary of the important bits that we learned in this module. First, objects can be created using object literals by defining properties inside braces like this. And we can easily add functions to object literals. If you're using existing variables to initialize property values in an object literal, you can use the shorthand syntax like this if the desired property names match the variable names. You can use object keys or for-in loops to inspect or loop over property names in an object. And we saw how to create constructor functions and use them to create new objects. We also learned that when it comes to comparing equality, double equals should be avoided. Triple equals and Object.is are identical, except when comparing not a number and comparing -0. Now it's time to dig deeply into object properties. There's a lot more to learn about object properties than you might think, so let's take a look.